Hello everyone. So in this second video, we'll be learning about rational and irrational numbers in detail. So in the previous video, we did learn about the natural numbers, the whole numbers and the integers. So in this section, we'll be starting with the rational numbers. So rational numbers, these are the numbers which can be represented in P by Q form. The rational numbers are represented by Q, and when we are representing a rational number in P by Q form, P is the numerator and Q is the denominator. And now we have specified that the denominator cannot be equals to 0. The reason is because division by 0 is not possible. So we'll just try to remember this with some examples. If I say what is 0 by 2, so prompt answer will be 0. And if I say what is 0 by minus 10, again you will say that this is 0. Why? Because whenever the numerator is 0, the answer of the fraction is 0 always. But what if we take the converse of this? Suppose I say 2 by 0. Now we know that division by 0 is not possible, so you won't get any answer. So this is a not defined form. Similarly, for the negative number, if I say that minus 10 by 0, now again we know that division by 0 is not possible. So again this will be a not defined form. So as we were continuing with the rational numbers that the denominator cannot be equals to 0. So what could be the possible examples for the rational numbers? Suppose I say 3 by 5, or we can say minus 1 by 4. So the positive fractions and the negative fractions come under the categories of the rational numbers. So these are basically the fractional numbers. So what if I say minus 2? What if I say 6? Are both the numbers rational numbers? So one can say that minus 2 and 6 are integers, but these are rational numbers also. Now you would have a question, you might have a question that these minus 2 and 6, these two numbers are not in the fraction form. They are not in P by Q form, but every integral value can be represented in P by Q form as each number, each integer value is divisible by 1. So these number can be represented in P by Q form. So these are the examples for the rational number. Now we have another point, that is irrational numbers. So irrational numbers are the ones which cannot be represented in P by Q form. They are represented by S. So what are the possible examples for such numbers which cannot be represented in P by Q form? It comes as, say, under root 2, under root 3, under root 5. So all these numbers, or the cube roots, the nth roots, they come under the categories of irrational numbers. So for example, if I say what about under root 4? Is it a rational number or an irrational number? We know that under root of 4 is equals to 2. Now 2 is an integral value, and every integral value can be written in the P by Q form by taking denominator as 1. So under root 4 is equals to 2, which can be written as 2 by 1. So it is a rational number but not the irrational number. Now, learning more about the rational and the irrational, we need to go through the decimal expansion of the numbers. We know that the decimal expansion can be a terminating one and a non-terminating one. What do we mean by a terminating decimal expansion? Suppose I say if we divide 5 by 2, what we'll get? We'll get 2.5. If I say if we divide 5 by 4, what will we get? 1.25. So in the very first case, the decimal expansion ends after only one decimal place. And in the second one, after two decimals, our division ends up. So this is the kind of terminating decimal expansion. So what we can say from here, rational numbers are those which have terminating decimal expansion. Now coming towards the next category, that is non-terminating decimal expansion. So non-terminating decimal expansion can be repeating or recurring, or it could be non-terminating but non-repeating. So we need to know what does it mean by when the decimal expansion is non-terminating but repeating. So if I say if we divide 10 by 3, so what answer do we get? So 10 when divided by 3, the decimal expansion should be 3, then it would be 1. So as we can see that this decimal expansion does not ends up, and we get 3, 3, 3, 3, 3 repeating. So you can say that the decimal expansion is 3.333 up to so on. So for the ease purpose, we can write this as 3.3 bar, as 3 is repeating again and again. So the decimal expansions which are non-terminating but repeating are under the category of rational numbers. So these are also the rational numbers. The ones which are non-terminating but repeating. Okay. So now coming for the last possibility, that is non-terminating and non-repeating. So this category comes under irrational numbers. Okay. So how? So if I say what is the value for root 2? For our convenience, we can say that root 2 is 1.414. But if you go through your calculators, or you simply go through the long division method that we have learned in class 8 to find the square root of 2 using long division method, you will find that the value for under root 2 is 1.414 up to so on, and the decimal expansion is non-terminating. You won't get an ending answer, and moreover the decimal expansion would be non-repeating. So the irrational numbers are those in which the decimal expansion is non-terminating and non-repeating. So I'm going to recapitulate this for you. So the rational numbers, okay, there are two types. Either they will be terminating decimal expansion, and if it is non-terminating, the decimal expansion will be repeating. And for the irrational numbers, the decimal expansion is always non-terminating and non-repeating. So in the next video, we will be learning to plot about the rational and the irrational numbers on the number line.